Rob Sherwood, NC0B.
Thank you, Tim. Well, each year, in the last several anyway, we talked about what came out in the last year for the contest season, now 2017 and 18, and using them on the air at my contest station, and then a couple other rigs that weren't new that I looked at again. So that's what's up for today. So what's important in a contest environment? Of course, we want to work the weak signals that are surrounded by strong signals, and that is what we call dynamic range. That we want a radio to handle that. Of course, in a de-expedition, everybody's working split, thank goodness, and so the CW signals calling are up 2 kilohertz or so, or in sideband up 5 or 10. So all those signals can combine in a receiver and intermod on top of the weak signal we're trying to work as our multiplier of this strange island somewhere. And we need a better receiver on CW than sideband, and I'll explain why that is. So here's the state of the art today, which of course is drastically improved over the decades. 100 dB dynamic range was unheard of back a long time ago, and now there's a lot of radios there. And we don't have to be right there, of course, within a normal range. The phase noise, and I'll talk about phase noise and explain this a bit. The technical description, what we'd like to see at a radio having around 145 dBc per hertz, but that's kind of hard to get your head around. But hopefully you've seen in QST the reciprocal mixing dynamic range, the RMDR numbers that are now displayed. And we'd really like that number to be about 10 dB better than the third order number, because most radios actually, that's the limit. So the rigs that have this level of performance, the flagship Icom, the 7851, all the Flex 6000 series, the previous ones and the current ones, and the Elecraft K3S, or if you have a K3 and upgraded the synthesizer. The newer Icom, the 7300 and the 7610, just a little bit below what that magic 100 dB number, which don't get obsessed on. The Apache 7000 DLE, the numbers are up where we'd expect, but the RMDR is not quite 10 dB more, but it's okay. But none of these radios here are what we call reciprocal mixing dynamic range limited or phase noise limited. So since last year, what's new? Well, we've got the 7610, which is the big brother of the 7300 that's kind of taken the world by storm for an amazing low price. And both of these, of course, are direct sampling, and the 7610 is a dual receiver. It's got dual ADCs, and it's also got solid-state TR switching and solid-state keying for your linear. Hopefully you have one that will key with its FET. That's got a relay too. And then in the audio peak filter, which of course doesn't exist on the 7300, which is a major thing for the CW operator. The Apache 7000 DLE, it's a 100-watt rig, unlike the 8000, and probably completely adequate. Certainly if you're driving an amplifier, you don't need a 200-watt rig. And then, of course, we've got the new Flex series, which you saw last year at Dayton, and has been shipping here in, I believe, started in February, with and without the M. The M is a built-in Maestro, which got knobs. So that's what's new for this season. So let's look at some numbers here real quickly. The dynamic range with the IP plus on, which is dither and random. Don't worry about what that means, but we're right 98 dB. The reciprocal mixing is excellent, and you'll see at 2 kilohertz, it's more than 10 dB above the third order number, so that's great. And it happens to have a very nice preamp, which is probably important on 6 meters. I don't know if you really need minus 142 on 10 in a quiet location, but 6 meters, pretty nice. And to compare the two, the 7300, it's kind of an anomaly. If we look at the wide space number, for some reason it's a little bit higher than the 7610, but let's look at the close-in number. They're basically identical. And again, you'll see at the 2 kilohertz reciprocal mixing dynamic range, it's more than 10 dB above the third order number. And of course, it's better than the 7300. If you look at the ads from Icom, you'll see they'll show their flagship, a little graph of noise. The 7610 is next, the 7300 is under it, and the 7600, the older radios, is below that. So that's what we'd expect, and that's how it tests out. The strange thing, though, is there's more variation than I would have expected when I measured the receiver. Now, I don't know how many of you have the 7600 receiver. No, just the 76, the 8600. I'm sorry, the 8600 receiver. Does anyone have that? It's a DC to light, and I've tested two of them. Adam Farson's tested one, and the league has, and there's been quite a bit of variation, like 10 dB. So this may be just sample variation from one ADC to the next. I don't totally have a handle on that. The Apache, here's some numbers on it, and so it's your 100 dB radio. That reciprocal mixing is fine. One limitation, though, is it really only has a noise floor of about minus 131, which on 10 and 12 meters in a quiet location, and particularly in some directions, like in my case, looking towards JA, it's pretty quiet. And that's not going to be completely adequate in every case. So you might need an external preamp on the 7000 DLE. But on 6 meters, it does have an LNA that's you can switch on, and it pushes the noise floor down. And so, of course, we know in 6 meters, band noise is less. So the Apache is open source as far as the software. It's written in most of it in the United States. I think the FPGA code's written out of the VK. They sort of have a new version 2. Of course, it supports the 7000. It has a spectral noise blanker, which is something that works well in a contest, and that's actually blanking on what's just in your passband, and that was worked out pretty well. It has some new noise reduction algorithms. The latency can be pulled down to really low numbers, but you've really got to fiddle with all the menu options, and I'm not sure how the average person would know what to do, so somebody needs to write up a white paper on that. It's got MIDI support, so as with possibly a lot of the radios that are really run by the computer only that don't have any knobs, this DJ console seems to be very popular, at least with the Apache Anon, and I guess Behringer has a similar product. And then it also has a lot of built-in audio tools, EQ and noise gates and all sorts of things that you might actually use with a separate product, but it's built into the software. So here's some number comparisons of the two new radios that may or may not have knobs. And when I first started testing the new Flex, I had my report done on February 24th, and there's some issues came up, and I shared this with Gerald. And we've been working together for the last 2.5 months, and just on Monday, the Flex announced their product enhancement, which would apply to anyone who bought a radio up through, I think, about April 12th. You probably got an email on that. So the issues that did come up have been resolved. And so if you look at the numbers, they're what you would expect. Dynamic range 99, reciprocal mixing there, wide spaced over 120, close in 115. So everything is fine now. But if you do have an older radio that came out in the first month or two, just go get the updates done, because you'll be where you expect the product to work, which is very well. Here's the contest that I used in the past season as far as what equipment I used and why. CQ Worldwide, the first 3 lists there, nothing was new at that point I could put on the air. So as you might remember, if you were here in previous years, the 7300, I'd run it on the ARRL 10-meter contest and a couple of 160-meter CW contests. I said, okay, it's time to try the 7300 on 20 meters because, well, 10 meters was pretty punk, as you know, in the past season. So 20 meters is your QRM special, so I said, let's try the 7300 there. I used my old 781 on the other bands except 20, and then 10 I used a TS990. So that's just sort of what I did since I didn't have anything to really report on that was a new product. The same thing was true for 160 CW with the ARRL in the first weekend of December. So I said, okay, I haven't really used the 7300 for a while, and my 990 was unfortunately wiped out with a nearby lightning strike, which has since been repaired. So I said, let's compare those. So I did that. Well, thank goodness, I got from DX Engineering by noon on Friday for the ARRL 10-meter contest. It arrived in Denver. My wife was nice enough to stay in Denver and drive it to my contest station east of Fort Collins, and I was all set up to drop it in the 3rd operating position and try out the new 7610. The next contest, of course, would be W1BB CW contest on 160. How many people are 160 CW contesters here? That's a modest number. It's an interesting band. And so the QRM is really, really heavy, particularly on the CQ and ARRL version, not quite as much on W1BB, but it's still a good test. I finally got a hold of a Apache 7000 DLE in time for CQ Worldwide 160 CW there in January. Since I'd had the 7610 for a while, I had more emphasis on the Apache. And then the last contest, again, nothing else to run, so I just went back to the 7610 and a couple of 7300s. So those are the contests I ran this year. So let's look at how the rig stacked up. The 7000 DLE was paired with the new Icom, and as I mentioned, I really wanted to give the emphasis on that. So I ran 12 hours on the Apache and about 4.5 on the Icom. Now these two radios couldn't be more different. We've got a completely computer controlled in one case, and of course we need either a lot of real estate or two monitors for the Apache. And I set them up as similar as I could. And there on 160 on Friday night, it was lots of interference and stations from 1800 to 1860. It was even worse on Saturday night, clear to 1880. So the Apache had requirements for extra software. I needed virtual serial ports to deal with N1MM, and also a tuning knob. I happen to prefer to tune with a knob. So either you needed a really big monitor or a couple of monitors, so that's what I did in that case. So there was the setup for the Apache. The left is N1MM. To control the radio beyond the tuning knob is sitting there on top of my speaker. If you wondered why is there a couple other monitors there, well, I was so afraid that something could happen, with Windows could crash or who knows what. So the gentleman that helped me set up all the software for the Apache, we set up a second spare computer. And I guess Murphy knew that because nothing went wrong with the main computer. So that's the Apache sitting on top of the Alpha 89. Now here's the 7610. Ignore the 2-meter rig with the watt meter on top. And for some reason, this is a 160 contest. All those rotators probably weren't used that weekend. So there's the Icom there in front of the keyboard. So this is what the band looked like on one of the evenings. It was interesting. I sat in on Bob N6 TV's talk today about waterfall, and I just really had used the spectrum scope, but I learned a lot about waterfall today, so that was interesting. So this is the display for the Apache. Now about 98% of all the software that runs in Apache now has been totally rewritten. Warren and our NR0V has written all the DSP code and all that, and the FTPGA has been written out of VK-LAN. But that probably looks familiar with you, and that hasn't really changed much. So I really used the band scope down at the bottom, but since I used really fairly narrow spans, like what's here, it's about 15 kilohertz, I didn't feel I was missing any ones, like Bob was talking about, that maybe you would miss a signal, but with that type, as you narrow the span, the resolution goes narrower and narrower, so it really can separate them out. So that's what I happen to use, but I'll learn some more about waterfall in the future. So the rigs were set up as almost identically. On Friday night, I used the 250 hertz bandwidth on both radios for the most part, but then the QRM was worse on Saturday night, and I narrowed it down to 100 or 150. Both have very good audio peak filters, and they were set up as identical as possible. I like a little bit of extra gain, and that's something you can adjust. I rather punch in the APF and actually have the audio come up a bit because the noise goes down, and it's a nice improvement that way. I used the spectral noise blanker on the Apache, which actually just looks at that 200 hertz bandwidth or whatever it is, and if there's some sort of a noise spike, it says that doesn't belong there, so I'm going to replace it with the sort of an average that where it should have been. So that's how that worked, and then in the case of the Icom, I used the noise reduction set on 3 out of 10. The other contest that I didn't have anything new was the ARRL 160, so I had, okay, let's go back to the 7300 and the TS 990. And I split it pretty much 50-50. and set them up as much equally as possible. So one thing that I want to emphasize is maybe people think, well, I don't want to run an attenuator. That'll gonna make the signals weaker. But on the lower bands, we really want the AGC threshold to be above band noise, because really don't want it, anytime there's a pause, you really don't want band noise to be equally loud to the signals you're working, because that's really tiring. So that's how I set it up. And so the little Icom only has a 20 dB option, period, or the RF gain. So I set the Icom at 20, and I set the TS990 at 18, and that was a little more attenuation than I'd run in the past, but I really liked that. I did have to turn up the AF gain, the volume control, on occasion on a weak station, but for the most part, it pushed the AGC threshold up high enough that band noise was almost not tiring, and that was kind of amazing. So how did these two compare? Well, the QSK of the Icom is far inferior to the Kenwood. The Kenwood has solid-state TR, solid-state to key the linear, where the Icom has relays that make noise, and they're not all that fast, and you can't do QSK at 30 words a minute at all. So the Kenwood really won there. The noise reduction, though, on the Icom was better. And actually, this was surprising. The band scope, even though it's small on the 7300, I felt the band scope gave me more detail than the bigger band scope on the Kenwood. Now, the front end of the Kenwood is far superior. Just a reminder, the 7300, if it's on 20 meters, the front end's only down about 10 dB on 40 and down about 10 dB on 17. So that's pretty broad, where the Kenwood's got a much sharper front end, plus a tracking preselector. So if you were in the East Coast, opposed to me in the middle of nowhere in Colorado, then that front end of the Kenwood would have come out on top. So what's some of the contest features I feel are desirable? Well, if you're in a CW contest, I think you really like a rig that does QSK well. And if you don't want to hear between every dit, so set it up for semi-break-in, but we don't want any audio artifacts that are clicking away for 48 hours. That makes you tired. And I think the APF is almost mandatory if you're really serious, although you could use some sort of an outboard audio filter, which still exists. I can't imagine not having a band scope today. And of course, it can be external, but built-in's really great. And again, as Bob said, you're kind of running blind today without, whether you're trying to find a multiplier or you're just running S&P. We need a good user interface. Either we don't want to have to go into menus during the contest, and we don't want to have anything that's slowing us down. And that's why I like a tuning knob, even no matter what the radio is. Apparently the DJ console is really popular with the Apache product, so that sort of fits what you would expect there. So now let's look at some numbers, some techie nerd stuff here. What do the state-of-the-art numbers mean? And if we have an older radio, how are we going to make it work as best possible? So let's explain dynamic range. If you don't know, we feed in two signals that are equal in strength, and we keep increasing those two signals in the laboratory until the third order intermodulation product equals the noise floor. And that's just how it was defined in 1975 in QST and Ham Radio Magazine. So to give you an idea here, let's say the noise floor of the radio is minus 128 dBm. Even if you don't think dBm, just consider this is a number here. And if you fed in signals that were minus 28 that happened to be equal to the noise floor, then that was your magic 100 dB radio. So that's just how it works out. So we know exactly where these distortion products are. If we have two signals 2 kilohertz apart, then we know that that distortion product that we want to measure is 2 kilohertz up from the high side and signal and 2 kilohertz below the low side. So we don't have to go wandering around looking for it, but we do need to know it's really the third order product. So what I do is wobble the two generators one at a time, and that intermod product better wobble the same amount, or I'm not really looking at the right signal. So that caught me once about 30 years ago. Okay, back to phase noise, or this RMDR, reciprocal mixing dynamic range. It sort of was showing up in QST back a couple years before the 2013, but it's always in there now. There's a graphic there. We've got the color graphics where we've got little carrots and all that. This is really important, particularly for the radios that have been around for a while, because almost all radios, until we started seeing the K3S or the 7851 or the direct sampling radios now, almost all the radios were phase noise limited or RMDR limited as opposed to the third order product. So if you look at those two issues of QST, Bob Allison, who's the technical director, he's written two very good articles and really explaining that in more detail. You might want to look at that. So here's a graphic to explain what we're talking about. I found this on the web. And let's see that big tall spike there. That's going to be a perfect signal. Now, there is no such thing as a perfect signal with no noise on it, but let's just pretend we have one. And it's, you know, a kilohertz away from that little bullet nose signal that's weak, and that's our multiplier that's going to win us the contest. So every local oscillator in a legacy radio, superhet radio, it's got noise on the local oscillator. Now, if we go back in time, we had a Drake or a Collins or something like that. We had a PTO. That doesn't have much noise. We had a crystal oscillator per band. That doesn't have hardly any noise. But now as everything became synthesized, the first synthesizers were terrible, and they had a lot of noise. So what happens is that noise on the local oscillator or the clock in a direct sampling radio mixes with that really strong signal that is absolutely no noise on it, which of course doesn't exist, and it modulates that strong signal. So as you look over there on the right, that all that synthesizer noise gets put on top of the strong signal and then overlaps, and we can't copy the multiplier. So that's what phase noise is all about. So here are the radios that say pass that test. As I just mentioned, the K3S or the Herberling, which is mostly only in Europe, the Icom radios, the Flex radios, and the Anon. So we now have a situation where we're, unlike in the older days, 10 years ago, 20 years ago, the radios are not going to fail on this phase noise problem. So what I mentioned before about the Magic 100 dB radio, the example I gave, well, that signal at minus 28 dBm, which may be kind of meaningless number, well, that's S9 plus 45 over 9, and we certainly see signals that strong. So we're going to talk about that, but we're talking about dynamic range in reference to the noise floor of the receiver, but we have band noise, which is much more dominant, so that's another issue. Luckily, though, we can, if we run our radio properly, we don't have to have the absolute state-of-the-art, which is good because we certainly didn't have it 20 years ago when all we had were the first up conversion radios. Like the TR7 may have been the first in 1979, and we were kind of stuck with radios that were 70 dB plus or minus 5 maybe, clear up until 2003 when the Orion 1 came out. And then 2008, of course, the original K3 came out. That dynamic range of 70 plus or minus some was barely adequate for sideband contesting and DX and pileups and all that, but in CW it was not. And so, but luckily our radios aren't stressed to the max all the time, because if we were, all those radios we had for 20 years, that's all we had was up conversion radios, and we used them and made the best we could. So if they'd been stressed out, you know, failing all the time, of course something else would have changed a lot earlier. Here's a list from my website, and I took the receivers out. So this is just the top 17 transceivers that happen to go between 90 and 106. And any of these will work just fine if you use the radio properly. Let's don't turn the preamp on 80 meters at night. And so we've got a lot of choices that are radios of all different price range, different interfaces, whether they're knobs or not. And so we've got a lot of possibilities. You can look at the numbers. I won't go into detail. We've got it in there in your book. So why do we need a better receiver on CW than for sideband? Well, it comes down to transmitted bandwidth. A CW signal is about a kc wide, assuming we're sending something. I'm sure we're sending 599 because everyone is 599. But we probably have to send our CQ zone, or we have to send our ARR section. So we're sending it, and so we have key clicks. I mean, even if the radio is working right, every keyed CW signal has a bandwidth of about 1 kilohertz at minus 60. On sideband, our signal, believe it or not, is about 10 kcs wide at minus 60. So in CW case, the signals are clean enough that they will could cause overload, and then put intermod products right on top of that multiplier you're trying to work. But on sideband, it's very likely that the receiver is not the limit, it's the transmitted splatter. Now, I'm not talking about running our knobs at 11 like K1DG was talking about, or driving our amplifier that needs 50 watts of drive with 100 watts. No, we're running everything the way we should. We're running reasonable processing, reasonable mic gain, and we're not overdriving our linear. So here's what the bandwidth of a CW signal looks like, varying with the rise time. Now, most radios today, you can go in and adjust that. So this happened to be a 10 tech that I could go from 10 to 3. And the top one, which is wide, this was DITS at 30 words a minute. And then the bottom trace, which is much better, was at 3 milliseconds. Backwards. The top one's 3 milliseconds, the bottom one's 10 milliseconds. And 20 dB difference in your key clicks at a 700 hertz offset. Well, we ought to be able to work a station 700 hertz away from a really strong one. So be a good neighbor, whether you think, well, okay, I'm supposed to be a good neighbor on sideband, but let's not adjust our radios crazy fast rise times. And unfortunately, a lot of the OEMs will let us adjust it to 2 milliseconds or 1 millisecond. So if we look at this top graph, that at 3 milliseconds is way too wide. If we set it for 1, it's just going to be terrible. On sideband, now here's a way to look at our bandwidth. Now, instead of doing a two-tone test, which I'll show you in a moment, if we feed in band-limited white noise, this approximates speech, and we can get a nice graph. So this was a K3, and as you see, to get 60 dB down on the distortion products, the rig's running properly, we have to be 6 kilohertz away. Now, we also had data here from a Mark V in Class A. Now, I realize there aren't that many Class A, but in this case, we only have to be 1.5 kilohertz away to be down 60 dB. So we certainly prefer to have a much cleaner signal like that. But today, we've got what's called pre-distortion, and in the case of Apache, they call it pure signal. And this is better than Class A, sometimes 20 or 30 dB better than Class A. We don't have the heat problems. It's interesting that all the new amplifiers coming out have a port to go back into the radio if we want the pre-distortion, but at the moment, the only rig that I know of that accepts the pre-distortion type of improvement is this Apache. So hopefully this changes over time, because wouldn't it be nice in a contest if everybody's signal was virtually a rectangle with almost no splatter? As was mentioned earlier, some people like a wide signal to drive everyone else away, but that's not the way to be a good operator. That previous one, you sort of saw a rounded pass bandwidth. This is a digital radio, and in this case, it's got a nice square sides on it. It's flat across the top, but we've got to go 5 kilohertz away to get the splatter down 60 dB. So if I'm trying to work 2.5 kcs away from this guy that's gone CQ contest incessantly, I'm going to have a hard time. So if we could really get better signals on sideband, that'd just be wonderful. If you were to say, well, I'm used to looking at two-tone tests in QST, but here's superimposed on top of each other my test with the white noise from a general radio noise source, and there's the two-tone test. It gives you the same answer, so we're in good shape there. The one thing that I'd actually like better about the noise test is almost any radio on some band at some power level, the third order product, now those are the two that are next to the two test tones, is lower than the fifth order. So that seems sort of funny. So sometimes you might get a quoted spec that is sort of head scratcher, not really right, but you go to another band or another power level, then they would feed be the classic pattern of the odd order distortion products. But the white noise never does that. You never see a dip or some crazy thing. It's always monotonic and nice and smooth. So I really like this type of test. So how do we optimize what we have? maybe we own an 80 dB radio. The TS990, for instance, is about a 90 dB radio. It varies a bit from band to band because of its phase noise was actually the limit on most of the bands as opposed to third order. So let's just consider whatever our dynamic range is on whatever radio we own. Let's use it to the optimum possible. On the lower bands at night, we should be running attenuation. That way we're not going to overload it, and we really want that AGC threshold to be above band noise. So let's really run this the proper way. I talk to people all the time that say, I can't hear you very well, so I'm going to turn my preamp on 40 meters at night, and my band noise is S9, and now it's going to be 10/9. This is crazy. No, so then what is the significance of our receiver's noise floor versus band noise? And luckily we've got some really good data, at least out of town. So I'll show you why. This comes out of your handbook. It's the ITU data, and it's in a 500 hertz bandwidth, and that's great because that's what everything's quoted in QST or on my website for noise floor of a receiver. It's in a 500 hertz bandwidth just for standardization. Now, unfortunately, as time has gone by, if any of you have wall warts in your house or your neighbor has a plasma TV, we know that the noise in the urban environment is terrible, and that solid line on top, that's probably 10 or more dB higher today than when this graph was made. But the dashed line in the middle is very accurate in a quiet environment. And then the dotted one, which is called quiet rural, well, actually, I see quiet, almost, not quite, almost quiet rural at my QTH in some directions at some times of day. So to take those two lower ones, and this is really good data. And then unfortunately, I know when I'm mobile and I go through a town, I might as well sign off and say, I'll call you again another 10 minutes when I go through the town. So if you really are operating all the time in an urban environment, you know what it's like. Maybe you do some sort of a noise canceling type of device. So all radios are designed for 10 meters and now really 6 meters. Everything's got 6 meters on it. So the typical band noise on 10 meters with an omnidirectional antenna, because that's what the ITU data is minus 120 approximately. And 20 meters is about 10 dB noisier. Well, the typical receiver, probably without the preamp, has a noise floor approaching 130. So on 20 meters, we've got 20 dB to play with, but we want the receiver to be 10 dB better than band noise, because we don't want the receiver to have almost any significance as far as the amount of noise. So sometimes you don't need a preamp on the higher bands. It just depends on the opening. It's certainly 6 meter E-skip opening, you can have phenomenal strong signals. In that case, it's probably not needing that minus 142 dB noise floor. So, you know, use common sense. So if we take the data from that graph and look at the variation from 160 to 10 meters, the difference in band noise is over 30 dB. The top three there are at night on the low bands, and the last three are daytime. So we've got to say, we don't just set our receiver on one band and say that's fine for every band. This is actual measurements that made at my QTH here in actually 2013, and actually Gerald asked for that, and I thought, well, this is interesting, so let's do this. And you can see that where in red my data is within 1 or 2 dB of the ITU data, but that's in my noisiest direction, which is towards the Caribbean almost in every case. If you look at the bottom there where I have numbers in green, well, that's what my typical noise is towards JA, or in Alaska in my case, that's both the same direction. And then recently I've been measuring it on 20 meters, and I've been measuring minus 121 on 20 meters towards JA. So we really have a case where the ITU data being omnidirectional is right, but if we've got directivity, and I think a Yagi is more important as directivity in the QRM reduction, noise reduction, than the gain, whether it's 1 or 2 dB difference in gain, but the rejection is really important. So in this case, by knocking down the noise, it's great. So really, we would like the receiver to be 10 dB better than almost the quiet rural numbers. On the low bands, we probably talked today about verticals, two verticals, 4 verticals, 8 verticals, and so these voltage probe verticals don't need a ground system and all that, but you can get directivity or beverages on the low bands if you're lucky enough to have got the space. So directivity, again, really important. And as far as it knocking down QRM, it knocks down noise if you're in that favored direction. So let's look at one other thing is latency that is more an issue for particularly QSK guys on CW. The analog radios from the past were always fast, very limited latency, like in this case we see not even 6 milliseconds. I would say 20 or less is what we'd really like. The 7000 DLE, you can only get to 20 with lots of fooling around with the adjustments. And if we look back in time, before the adjustments, that the Apache was like 131. The Flex 6600M is at default is 106, so that's a bit long. But you can adjust that clear down to 58 if you do a trade-off on the filtering. So that does help. If we go back to, again, the 2016, we didn't have that option, so that's made an improvement there. So what's all this imply? Well, most up conversion, down conversion radios, they need some attenuation at night. There's no point in band noise reading upscale on your S meter. And you say, okay, well, that's what this means. What's this all about? As I mentioned, from a fatigue standpoint, we really don't want noise filling in every space in between words, in between the station you've tuned in. So we want to optimize that. And you may not need the preamp on 20 meters. And so just use the preamp when you need it, and let's use the attenuator where it's appropriate. I can't imagine ever needing a preamp on 40 meters at night or 80 meters either. Gain management is something we're going to have to learn to do better with direct sampling radios. The direct sampling radio in effect has a roofing filter as wide as the entire band because it's its front end selectivity, where if we had a legacy radio with a 500 hertz roofing filter, well, we can really goof up with our gain and it's probably not going to be quite as catastrophic. So we just need to realize that use the preamp appropriately. So this came up, this isn't in your book because this just came up May 1. This was a post on the 7610 groups.io group and Reflector, and here's, I'm going to quote it. People have said that, and this applies to any radio that's a direct sampling radio, people have said that the preamp 2 gives the best signal to noise ratio. If that's true, why not always use it? And then he said the clinker was, I'm in an extremely high noise area, compromised antennas, and I often can't hear signals that others can hear. So he's thinking, I've got noisy environment, poor antennas, high noise level, meaning reading, who knows, upscale, S7, something like that, and I think I should turn the preamp on all the time. And this is just backwards. So here's what I wrote him. Well, I wrote the Reflector. I said, if the S meter is reading upscale and band noise, there's no reason to use a preamp. And like I say, the classic radio, the legacy radio, superhet, you can probably get away with doing it backwards. But we really shouldn't be doing that with the direct sampling. And most of them have some sort of an overload flashing light. So you know when you're goofing up, but maybe you don't notice it. Now, if it's just flashing a little bit, that's not the end of the world. But we are really going to have to be paying more attention to how we manage our gain with the new architecture. So what are the basic things here? At 160 through 40 meters, we're not on 10 meters, we're not on 6 meters. We have too much sensitivity, let's use your attenuator. The published dynamic range can be a bit misleading, and I've got a little extra time here, so I'm going to go into this. In QST, there's a measurement that, particularly with the legacy radios, where the third order dynamic range is measured with a very narrow filter if the radio is phase noise limited. And it's a number that is valid, and it has meaning to the design engineer, but it doesn't really have much meaning to us. How many people run a 3 hertz filter on the air? No one's ever answered that positive. So, but it is a way to actually make a measurement. And this really came up in spades when the FTDX 3000 came out, and I tested it and published a dynamic range of 82 dB. And that sort of caused a big flap because the advertisement in QST said it was 100 dB, or I think 106 even. And then the league tested it, and they tested it with the 3 hertz filter, which was measuring the actual third order product, and they measured 100. But then if you looked at the fine print, the reciprocal mixing dynamics range was 82 dB, and that's what I had published on my website, was 82 dB. So we really need to know what these numbers mean, which one is dominant. So if you read Bob Allison's sidebars on the discussion of reciprocal mixing dynamic range, you can understand that whichever of these is lower. If one says it's 100, the other says it's 82, guess what? It's not 100. Also, I cannot approximate CQ worldwide CW with 2 signal generators. So talk to your friends. What are they running? What works for them and what doesn't? We need feedback from all of us. This is a hobby. We want to share our experiences. So we need to look at data, but then we need to look at the big picture too. I get people that'll call up and say, I've got a 95 dB radio. Should I sell it and buy a 100 dB radio? Well, this is nonsense. So we need to use some common sense because we've got a lot of choices. But then what beyond the numbers? Well, we need clean audio on receive, keep the fatigue level low. We'd like really clean audio on transmit. We would like reliable radios, good factory support and warranties, all this type of things. There's a lot to making a choice on a radio. Do you want to have knobs? Do you want to use a mouse? So I don't want people to say, well, I'm going to look at Rob's website, and the only thing I should buy is one radio at the top. I mean, this is crazy. So it's unfortunate that people get obsessed on one number because it's a much bigger picture than that. These passes, Tim said, there's several years worth of CTU videos that you can watch. And also, by the way, I have had the luck to be interviewed with Ham Radio, Ham Talk Live, and if you do just a quick Google search on Ham Talk Live, you can find 118 or so presentations over the last year and a half, and I've got one in there that's 5,100 people listen to it, so you might enjoy that too.